Okay, so, you know, what people did, immediately, somebody wrote down 600 for a point, right? If you let two of these equal 0, then you can easily find what the third one would have to be, and you've got a point in the plane, right? Or we could have written 0, -3, 0, or 0, 0, 24, right? And those are 3 points in the plane. Matter of fact, we're going to use those to get a picture of the plane. Now, those are your axis intercepts. We plot those and plot lines between the axis intercepts, and we get a reasonable picture. Okay? And that's a good thing to do. So that's good. Now, as far as finding a normal vector, I looked at what you did, and one of you had a pretty good looking normal vector, except it looked awfully bizarre to me, but now I understand what you did. Unnecessarily. Okay? So you came back here just to make sure everybody understands. If we have this form of the plane, and we expand these using the distributive law, what's the coefficient of x? Well, it's going to be a. Coefficient of y is going to be b. Coefficient of z is going to be c. So we could read off a normal vector, 2i minus 4j plus 1/2 k, right? Okay? Okay, so, so we get a bonus. We get 3 points just following what was done by the first paper I looked at for 1 point. So they'd be 600 obtained by letting y and z equal 0, so that obviously x has to equal 6. And similarly letting x and z equal 0, so that y is -3. And then 0, 0, 24, which you can also easily verify, right? And the normal vector, 2i minus 4j plus 1/2 k. Now, what one person did, just divided this by 12. It got this kind of into a form where we have 1 on this side, which isn't necessarily a bad thing to do. You'd want to do that if you had an ellipse or hyperbola, right? So it's a fairly natural thing to do and a good thing to do. It's pointless for a plane, but it's not a bad thing to have done, and it's not incorrect. And then you got 2 over 12, which is 1/6, and then you got -1/3, and you got 1/24, right? So I'll just write that down. Kind of pointless. Okay? But there would maybe be a point to having all these numbers be integers. Okay? In this case. Or 4i minus 8j plus k. Now we have whole numbers, so we don't have to deal with fractions, right? And there's some point to this.
Just to make your math easy?
Yeah, if you'd rather deal with integers, if you can visualize integers better than you can fractions, go ahead. There's no harm in it. Okay? I just realized I don't have the camera zoomed on the board, although it should still be legible. Okay, so there's some point to this, or four squared is 16, 8 squared is 64, and coincidentally this vector has magnitude 9. Now if you don't like dealing with fractions, well, we just divide the whole thing by 9, but this is a unit normal, okay? So these are unit normals. Really not important for the equation of a plane, but very important elsewhere, so it's worth mentioning. With some of the other stuff we're probably going to get done here in a little while. It's nice if you've got a curve to have a unit normal to the curve. And sometimes if you've parameterized a surface, to get a unit normal to the surface, okay? For various things that are coming up, okay? Well, that's more than you need to know. All you really need to know is you can get these 3 points, that's important, okay? And you get a normal vector, and any one of those points in the normal vector tells you where the plane is, okay? Now, can you point in the direction of space, or can you run your hand over the plane? If x is in this direction, y is in this direction, z is in this direction. Think about that for a minute.